Hi everyone, my name is Thomas Kim. Today is January 30th, 2020. This is my 14th episode about 3D graphics, Intel TBB, OpenCL, Vulkan, Direct 3D 12 using Microsoft Visual C++. In our previous episode is also 14, but the title is different. In our previous episode, Parallel Algorithm 1, this is Parallel Algorithm 2. So, if you want to follow my current session, you have to watch my previous episode. Otherwise, you may not understand my current session. The click count of my previous episode is very low. But I don't worry and I don't care. If you have watched my previous video and also watched this episode, you will learn something that nobody can teach you. I promise. You will learn something that absolutely nobody can teach you. As I said in my previous episode, don't implement parallel algorithm by yourself. Use Intel TBB or threading building blocks. Intel TBB seamlessly integrates with OpenCL C++ interface, and further, Intel TBB will be incorporated into Intel oneAPI Toolkits, which is based on SYCL, the C++ language interface for heterogeneous programming, using both CPU and GPGPU. For more information about Intel oneAPI Toolkits, please double-click this link. Intel oneAPI products will deliver the tools needed to deploy applications and solutions across SVMS architecture. SVMS means a mix of scalar, vector, matrix, and spatial architecture deployed in CPU, GPU, AI, FPGA, and other accelerators that is required to extract high performance. With oneAPI Toolkits, Intel introduced Data Parallel C++ compiler, an evolution of C++ that incorporates SYCL. Once you learn Intel TBB, then OpenCL or SYCL, today your life as a C++ programmer is guaranteed for next 30 years. Invest your time for your future career. But don't get me wrong. When I say don't implement parallel algorithm by yourself, I don't mean you should not implement the parallel algorithm yourself. I rather mean it. You should learn the fundamentals or the essence, but not wasting your time by reinventing the wheels. The syntax of C++ 17 and C++ 20 is very different from that of C++ 98, but the fundamentals of C++ programming hasn't changed a thing. The language can change, but the fundamentals remain the same over time. I hate anything that is ambiguous. I will give you a concrete example of fundamentals. For example, learning how to apply recursion or induction or recurrence relation to your programming belongs to the fundamentals. Another example will be understanding how to use indirect indexing. Such fundamentals cannot change over time. You can apply these things to any programming language. If you are familiar with recursion, C++ template metaprogramming is just a piece of cake. In the YouTube, search for compile time loop. These are all my videos. Nobody ever talks about compile time loop. Once you understand what is compile time loop, advanced template metaprogramming is just piece of cake. It's really simple programming technique. I want to help my audience learn the fundamental techniques that does not change over time. Without further ado, let's get started. Scroll down in the download source code section. Please double click this link. We need the source code from our previous episode. Show in folder, unzip it, rename to, copy the folder, paste it to your working folder. This is my working folder. Start your Visual Studio Code. Open the folder, click this folder, algorithm 2. Double click it, Ctrl B. This is the state of our previous session. Scroll down, find test CPP threading basic. Copy this function, copy. I will make demarcation and paste. Scroll up, test CPP threading intermediate. Change your function name like this. Now copy the function name, scroll down, paste it here, disable it, start your command prompt, dir cd 14 split range parallel algorithm 2 dir cl ehsc std c++ 17 split range .cpp fe m.exe, hit enter. M. Here, please remember that the type of F1 and F2 are std future double. Here, double is the return type of this function. Scale it. Now, we need its return type. So, using return t, scale it, we are calling this function with this type, size t. So size t, size t. Now we are making into a type, DECL type string, the type of return t. Talk, play, fun, get type, name, and there. We have to provide type. Now we build again CLS M. The type of return t. We build again CLS. The type of return t is double. Now we will use this type shortly. Disable this part. In our previous episode, we used size t like this. Instead, I will remove it. Okay? Then scroll down. Scroll down. Now, we know the type of F1 is std future double. So, using future t std future return t, we defined the type of future using return t, return type of scale it. Now we are creating a vector std futures t. This is plural std vector future t, vector of std future double. Okay, now I will delete this part. Now we create futures. We create an instance of std vector std future double like this. Now for size t, we start with 1. I less than range count. We split the range size plus I. Okay, we start with 1. So future implies spec std async std. I will just copy this part. Okay, I will just copy this part because it returns future. Then it should be I. Now we don't need it. Now this part is the same. Now we can convert this part like this. Futures 1 or futures 2. So I will disable this for auto app futures. These futures are this vector of future. Now we are translating this part. Sum of scares future get. Now start command prompt once again. CLS voila, the same. Now we can print out thread ID here. I will create a mutex. Control home. After TBB parallel include TBB spin mutex. Control End. Here using mutex TBB spin mutex. Mutex mutex. We will capture this mutex. Now here we create another block. Mutex scoped lock mutex. Stream processing start end thread ID std this thread get ID and there. Now we run again CLS. Now we can see processing 07. 1 thread, 2 thread, 3 thread, 4 thread, 5 thread, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 threads are running simultaneously. Now here stream main thread ID std this thread get thread ID. Now we build once again CLS. So this is main thread. This range is executed using main thread. Please note that I will copy this part, copy, paste it here, and I create a block auto app. I copy this, cut, paste, app. This code does not work. Ctrl K, Ctrl C. This code does not work. Also again here, I will copy it, Ctrl K, Ctrl C, This code may not work or does not work. Why it does not work? Why it does not work? I will answer these questions in my next episode. In my next episode, I will finalize this program into a complete parallel algorithm as we have seen our previous episode. Right-click, go to definition. In my next episode, we will turn this function into a complete algorithm like parallel reduce. Please subscribe to my YouTube channel. Thank you for watching.